All right, we're going to go over the answers for the light and color quiz and at the same time do quite a bit of review to get you ready for the exam that's coming. So these questions will help us review quite a bit so you can be marking things down on your quiz that would help you to study and get ready for the exam as well. Plus, I'd like for you to grade your quiz while we're doing this, and we'll talk about how to grade those questions as we go through them as well. Okay, so let's look at number one. Number one says, which of the following electromagnetic waves has the highest energy? The correct answer is B, X-rays. So that's going to be +1. So if you got number one right, put +1 next to it. The multiple choice questions are going to be 1 point each as we go through them. Quick explanation. Remember electromagnetic waves, a couple really important things about them. One, they all travel. Here's a picture of the electromagnetic spectrum. They all travel as transverse waves. They all travel at the same speed, which is the speed of light, which is 300 million meters per second, or 3 times 10 to the 8th meters per second. And the electromagnetic spectrum organizes different types of electromagnetic waves according to their properties. So here's some important things. If you don't have them or know them, you're not going to be able to access the electromagnetic spectrum on the exam. You need to be able to know where these items are off of the top of your head. So you're going to have to do a little bit of memorization or whatever it takes. So from left to right, the energy increases. So radio waves would have the least amount of energy. Gamma rays would have the most amount of energy. There's X-rays right there. That's why the answer to number one is X-ray. Remember that wavelength increases as you go from left to right. So actually, I have that wrong. That's not right. This actually goes like this. Oh. Well, let's see if I can change that. All right. Sorry about that. When I wrote that, I wrote those two in the wrong spot. So let's let's try that again. Wavelength decreases as you go left to right. You can see the waves right here. That's why I knew I was wrong right away. Large waves and small waves over here. So the smallest wavelength would be gamma rays, and the largest wavelength would be radio waves. Frequency, which is what we're dealing with down here, frequency then increases as you go left to right. Remember, wavelength and frequency are inversely related. They're opposites of each other. So since they're such small waves, they have a high frequency. Last thing is the danger. So it might say which of the waves are the most dangerous. Remember, the smaller waves are most dangerous because they can hurt our bodies and penetrate things that larger waves can't. So as you go left to right, they become more dangerous. That's why you got to be careful with UV waves, X-rays, and of course radiation in the form of gamma rays. So all that for number one. Number two says light shines on a pane of blue glass and a pane of clear glass. The temperature will be higher in the blue glass. That would be letter C. Remember that if the glass is blue, that means it's absorbing light waves and reflecting blue. If it's clear glass, it's just going to pass right through. All right, number three. Cyan is really a mixture of blue and green. We spent some time looking at these primary colors. And so when we talk about cyan occurs when blue and green are mixed together. Remember, we had two different types of colors, primary colors. We had the additive. This is when we're adding light together. So this would be like lights on a computer screen, or lights on your phone, or lights on your TV. That's why red, green, and blue make up all the different colors on your TV or on your computer screen. Those pixels are tinted a certain amount of red, green, and blue. And it gets lighter and lighter, and eventually, if you have all red, green, and blue together, it would be white in the middle. It's color by addition. Color by subtraction would be primary colors magenta, yellow, and cyan. and we're absorbing more and more light as you're actually adding pigments or paints or colors together, and it's going to be black when it's in the middle. These would be things like printing a magazine, developing a picture of an actual photograph, mixing paints together for art. This would be the primary colors of pigment. All right, let's go to number 4. My yellow sweater appears yellow because the color blank is absorbed. So this one's a little bit tricky. So you need to be able to understand the colors and how they work. So the answer is blue. Let me show you my beautiful drawing here of this yellow sweater. Remember that when light comes from the sun, it comes in equal amounts of red, green, and blue. Those together make white light. If your sweater is yellow, that means it's reflecting red and it's reflecting green. So that means that the blue color is absorbed by the sweater, right? And so we have that. If the sweater was red, that means it would absorb green and blue, and red would be the only thing that would be reflected. And so we have that. Now, we did also talk about colored filters. If there was say a red filter in front of my eye, well, then that yellow sweater would only look red because the green would get absorbed by that red filter. Remember, filters only let the light pass through that matched the color of the filter. If it was a green filter in front of my eye and I was looking at this yellow shirt, then it would be green. If it was a blue filter in front of my eye, well, then there's no blue to pass through. That yellow filter would actually look black. That yellow sweater would actually look black. So remember that the filter would only let the color pass through that is the same as the color of the actual filter. All right, so keep marking these right and wrong. That was number 4. Number 5, polarized sunglasses work because they are oriented at 90 degrees to each other. Remember, they have different orientations, and they're going to be at a 90-degree. Number 6, polarized filters are translucent. We have these 3 terms. Translucent means some light waves pass through, some are blocked, and some are absorbed. Transparent means all of the light waves pass through. Opaque means none of the light waves pass through. They're either absorbed or reflected. Number 7, if I were to move a light 4 meters to 2 meters, how would that change the illumination? It would be 4 times as much. So let's look at the equation. So here's the E equals I over D squared equation. Remember, E is illumination. It's measured in lux. I is lumens. It's measured. I is illumination, or intensity. It's measured in lumens or candelas, and D is distance. So if I decrease the distance, which is what the problem said, let's make sure I'm talking about this right. If I decrease the distance, so it was 4 meters, now it's going to be 2 meters away. If I decrease the distance, the illumination is going to go down because we're dividing by less. But how much down is it going to be? Well, it's cut in half, and because it's squared, it's going to have more than an impact. It's not just going to be one. I'm sorry, let's try that again. If we decrease the distance, we're dividing by less, so the illumination is going to be higher, right? It's going to be more because we're taking that light and we're putting it closer to the table. But it's not just going to be 2 times as much. Because that's squared, it's going to be 4 times as much. So if you decrease the distance, the illumination goes up by the square of the number. If you increase the distance, the illumination would go down by the square of the number. If you increase the intensity, the problem doesn't say that, but if you increase the intensity, you just increase the illumination by the same amount. If you decrease the intensity, have a less intense bulb, you would have less illumination by the same amount that it's decreased. So that's how the E equals I over D squared equation works. All right, number 8. Last one. If I were to change the intensity of a light source, oh, that's what I just said a second ago. If I were to change the intensity of a light source from 4 lumens to 2 lumens, how would that change the illumination? So I'm just decreasing the intensity. There's no squared on the I in the equation. So if I'm just cutting it in half, it's just going to be half as much. So number 8 would be C, half as much. All right, so those are 1 point each. The problems here, 9 and 10 and 11 are going to be 4 points each. And so here's how you would do number 9. Number 9 says if we discovered the Michaux star system that is 1.5 times 10 to the 21st meters away, how long would it take for the light to reach us? So this is what we have. We have a distance of 1.5 times 10 to the 21st. Remember that E button replaces the times 10. We know that this is going to be a light wave, so it doesn't tell us the speed. We need to know the speed, and the speed is 3 times 10 to the 8th meters per second, right? Light waves, radio waves, all electromagnetic waves, even if we don't tell you in the problem, they all have a velocity of 3 times 10 to the 8th meters per second. And we want to know what the time is. So V, D, and T are related with velocity equals distance divided by time. Now I'm plugging these numbers in. V is 3 times 10 to the 8th. D is 1.5 times 10 to the 21st over T. I need to solve for T. Well, we're going to cross multiply then. So the 1.5 E21 would be times 1 right here. So that's put that right there. That's going to equal 3 times 10 to the 8th times T, which is going to be right here. Then the next step is to get T by itself. We divide both sides by 3 times 10 to the 8th to get our answer. Our answer is 5 times 10 to the 12th seconds, or 5E12 seconds. So if you got that all the way right, that's 4 points. If you forgot the unit, it's just going to be 3.5 points because you forgot the unit. If you set up the equation right, but you just had a math error somewhere along the way, but you did have V equals D over T, and you did have 3 times 10 to the 8th meters per second, that'll be 3 out of 4. If you showed all your work, but used the wrong equation or got mixed up, but you showed your work, it'll be 2 out of 4. All right, next one, number 10. Similar process, different equation. If the wavelength of a gamma ray is 1.25 times 10 to the negative 10th meters, what would the frequency be? So we know what the wavelength is, 1.25 e negative 10. We know the velocity, it's a gamma ray, so it's going to be going the same speed, 3 times 10 to the 8th meters per second. We want to know what the frequency is. So now instead of linking these 3 with V equals D over T, we can link them together with this equation, V equals F lambda. So now I know this is kind of all written down all at once here, but you hopefully can see this. The velocity I put in here, the frequency I left, and I multiplied it by the wavelength, which is right here. Now to solve that, we need to just divide both sides by 1.25 e negative 10 to get F by itself. So 3e8 divided by 1.25 e negative 10, that gives us 2.4 times 10 to the 18th hertz, or 2.4 times 10 to the 18th hertz for our frequency. Same process, 4 points if you got it all the way right. If you forgot the unit, it's going to be 3.5. If you had all of the work, but somehow you made a math error, that would be 3 out of 4. If you showed your work, got an answer, but used the wrong equation, it'll be 2 out of 4. If you just put a random answer on either of these with no work and it's wrong, you don't get any points because you didn't show your work. All right, last one. All right. So we have, I shine the overhead machine in your face with an illuminance of 26.5 lux at a distance of 4 meters. What would the intensity of the light be? So the illumination is 26.5 lux. The distance is 4. I don't know what the intensity is. So here's our equation, E equals I over D squared. I'm putting in 26.5 here. I'm putting in 4 there. And I have my I up here. So 4 squared is 16, and to get I by itself, instead of dividing by 16, we multiply both sides by 16. So that's why I have I equals 26.5 times 16. That's just doing our math here. We don't have to cross. You could cross multiply if you wanted to. It would be I times 1, which would be I, equals 26.5 times 4 squared, which is 16. And then you would be in the same position. I equals 26.5 times 16. You get 424 lumens. 4 points, 3.5 if you missed the unit. 3 out of 4 if you showed all your work, but maybe you had a math mistake. You have to have shown this equation. But if you showed this equation but then made a math error, it'd be 3 out of 4. If you wrote some things down but never got to this equation, but you tried, it's 2 out of 4. If you have a random answer but the answer is wrong, it's 0 out of 4. So hopefully that's a good review. If you need any other help, please reach out to me. I'm available after school. I'm available in the morning tomorrow. I'm also available during advisory tomorrow if needed. So there's different options for you. So please put a score out of 20 on your quiz, and then use this as a review. Bring your quiz with you tomorrow, and be ready for the exam. Thank you.